In this video, I'm going to be talking to you about how to solve simultaneous equations using the method called elimination. There is another method called substitution, but that will be covered in a separate video. So I first want to talk about exactly what we mean by simultaneous equations. So if, for example, I gave you the equation 3x plus 4 equals 22, we could actually solve this equation. Take 4 from both sides, 3x equals 18, so x must be 6. Now, if you're not sure how to solve equations like this, then you need to watch another video on that. But for now, I'm going to assume that you can solve normal equations and continue with the simultaneous equations. So this equation is a relatively simple one to solve, and there is one solution. 6 is the only value of x that will work. There is no other value for x that will make this equation work. But what if I gave you a different example? 3x plus y equals 22. Now we could choose the same values as before, where we had x equals 6, so 3 times 6 is 18, so y would be 4. But instead of 6, I could have chosen a different value for x, say 1. And if x was 1, 3 times 1 is 3, so then y would need to be 19. I could have picked x is 2, in which case 3x would be 6 and y would be 16. Now we could actually continue going on and pick any value of x we chose, and we don't even have to stick to whole numbers or positive numbers. We could choose negative numbers, fractions, decimals. So there are actually an infinite number of solutions to this. There is no single solution. And if we wanted to, we could even plot the results on a graph to show all the possible solutions in a particular range. Now I've done a quick sketch of the graph over here just to show you roughly what I mean. But for example, this solution here corresponds to the value x equals 6, where y equals 4. If we were to choose the value x equals 5, we would have 15, so we'd need to add on 7 to get our 22, so y would be 7. So all the points on this graph correspond to a pair of values that work in this equation. Now we haven't actually solved anything yet because there is nothing to solve. This at the moment is just a relationship between x and y, and any value on this line, any pair of values on this line would work. But what if I also told you that x minus y had to be 6? Suddenly this reduces all the possible values down. For example, our solutions x equals 6 and y equals 4 work for the top equation, but they don't work for the bottom relationship because 6 minus 4 is 2, so that rules out that possibility. It also rules out 1 minus 19, 2 and 16. The actual pair of values that would work in this case are where x equals 7 and y equals 1. Now I knew that, but we use simultaneous equations and methods of elimination to find these values. So that is actually what we mean when we're saying solving simultaneous equations. We are finding the pair of values that work in two equations. Now, you might be wondering if there might be more than one solution. If we think about the second equation, x minus y equals 6, we could find pairs of values. So we could say x equals 6, y equals 0, x is 7, then y would be 1, x is 8, y would be 2, and so on. So we could plot these points on a graph as well. X is 6, y is 0, and we could plot x is 7, y is 1, which would be over here somewhere. 8 and 2 would be up here. So this one would actually make a straight line too. So if you think about all of the solutions to the first equation being on the black line, all of the solutions to the second equation being on the pink line, there is actually only one place here. There's only one solution that works. So x is 7 and y is 1 would be the only solution that works. So the reason we couldn't solve it with just one equation is because we have two unknowns. We have two variables that we don't know the value of. But if we add in a second equation, that gives us enough information to be able to solve and find the exact two values that work. If we had three unknowns, we would need 3 equations, 4 unknowns, 4 equations. So you need as many equations as you have unknowns to be able to find an answer. Now it's important that the equations are different equations, giving you a different relationship between x and y. For example, if one of the equations was x minus y equals 6, and the other equation was 2x minus 2y equals 12, these are effectively the same equation, because if we think about having two lots of this top equation here, we know from this that if we had two lots of x minus two lots of y, then the total would be double, would be 12. So this equation is just the same relationship as the top equation. So that is not enough information. You need two different relationships, two different equations between x and y. Let's have a look at an example then. So if we had the two equations or two relationships, x plus 3y equals 9 and x plus 1y equals 5, we can use these two equations, as they are two different equations, to work out exactly the values of x and y that work for both equations. So if we think about what this top equation means, we've got one lot of x and three lots of whatever y is, add together to give you 9. Now x and y are just values that we don't know what they are. So I'm going to draw this out using a square to represent an x and a triangle to represent a y. So from the top equation, we've got 1x, 1 square and 3 triangles, giving us a total of 9. From the second equation, we know that 1 square, one lot of x, added to 1 triangle, gives us a total of 5. Now laying it out, drawing it out like this makes it a bit easier to see exactly what's going on. From this bottom equation here, we can see that this square and this triangle, 1 square add 1 triangle, must be a total of 5. So to get our total of 9, we need 4 more. So these two triangles here must be a total of 4. Now if two triangles add up to 4, each triangle must be worth 2. We can then see from the bottom equation that if the triangle is worth 2, each square must be worth 3. And if we double check that in the top one, so a square is 3 and a triangle is 2, we've got 3, 4, 5, 6, 7, 8, 9, which gives us our total of 9. So to do it without drawing squares and triangles, we look at the two equations. So in this top equation, which I'm going to call equation 1, we know that we've got 1 lot of x and 3 lot of y, giving us a total of 9. In the second one, I'm going to call equation 2, we've got 1 lot of x and only 1 lot of y, giving us 5. We can see straight away that we have the same number of x's in both equations. So we can directly compare the equations. If we take this second equation away from the first one, we can eliminate the x's. If we take the whole of this side, which is x plus y, away, then because that's a total of 5, we have 5 less in our total in the first equation. So we're taking the first equation and taking away the second equation. So if we have 1x in the first equation and take away the 1x from the second equation, we've got no x's. If we've got the 3y in the first equation and we take away the 1y in the second equation, that would leave us with 2 lots of y. Now because we had a total of 9 in the first equation and we've taken away the whole second equation, which is a total of 5, that would leave us with 4. So we do 9 take away 5 equals 4. This gives us our 2y equals 4, so 1y must be 2. We can then put the y value back into equation 2, so x plus y, which we now know is 2, is equal to 5, which gives us x equals 3. So we've got two values, y is 2 and x is 3. We've used equation 2 to find the value of x, so we now check that they both work in equation 1, because remember we're trying to find the values of x and y that work in both equations. So if we check x, which is 3, plus 3 lots of y, so 3 times 2 is 3 plus 6, which equals 9, which is the total of our top equation up here, so that is correct. So we know that our values of 3 and 2 are correct. that was a nice easy example with small numbers. Let's look at a slightly harder example. Okay, so in this example, we can't directly compare because we don't have the same number of x's or the same number of y's. So at this point, we can't eliminate either the x's or the y's. So if I call this one equation 1 again and this one equation 2, it helps to see what you're doing. It's good to keep track of what you're doing. We want to be able to directly compare, so we need to get either the x's or the y's the same. So I'm going to look at this second equation, and if I took 3 lots of the whole equation, we'd know that the total would be 3 lots of 15. Now 3 lots of 3x is 9x, 3 lots of y is 3y. So if we've got 3 lots of the left hand side, that must mean that we've got a total of 45 on the right hand side. So this now gives us a third equation, which remember is the same as equation 2. They are just different ways of expressing the same thing. So what we can now do is use equations 1 and 3 to do our elimination. So equation 1 is 2x plus 3y equals 17, and equation 3 is 9x plus 3y equals 45. Now, I've deliberately written equation 3 above equation 1 because the numbers are bigger and it just makes life a little bit easier. So now it's the y's that are the same this time. We've got 3y and 3y. So it's the y's that we're going to cancel out. So this time we're again take this whole second equation away from the whole top equation. So we do 9x, take away 2x to get our 7x. The reason we're taking away is so that this 3y take away 3y cancels out, and that must mean our total is 45 take away 17, which is 28. So if 7x equals 28, then we know that x equals 4. The process is then the same as we did before. I'm going to use equation 1 and plug my x value into equation 1. So 2 times x, which is 4, plus 3y equals 17. So 2 times 4 is 8. 8 plus 3y is 17. Take the 8 away. 3y is 9. And then divide that by 3 to get y equals 3. Now remember, they have to work in both equations. So I'm going to check in equation 2. And 3 times my x, which is 4, plus y, which is 3, gives me 3 times 4 is 12, plus 3 equals 15, which is what we wanted to get up here. So these values are correct. So now we know that we can make the coefficients, the number in front of either the x's or the y's, the same by multiplying through the whole equation. So in this example, we multiplied the whole of equation 2 by 3, and that gave us the 3y to match the 3y in our first equation. Let's have a look at another example then that's slightly different. So here's 2 more equations. So we've got 2 unknowns, 2 equations, so we should be able to solve it. Now we could, in this case, make the x's the same by multiplying this equation by 5 and this equation by 6 to give us 30x. However, I'm going to make the y's the same instead because it keeps the numbers a bit smaller and I only have to change one equation. So again, let's call it equation 1 and equation 2. And this time, to make the y's the same, I've got 2 y's here, so I need to multiply my equation 2 multiplied by 2. So I'm going to double what I've got on the left hand side of the equation, which means I'm going to have to double what I've got on the right hand side. That's the bit people often forget to do. Don't forget to multiply the right hand side as well. So 2 lots of 5x is 10x minus 2 lots of y equals, and I need to double my total, so that will be 6. And then I'm going to just write out, I'm going to call that equation 3 and write out equation 1 again underneath. Remember, we've used, this has come from 2, so we can't use 2. It's an equivalent expression to 2, so we need to use equation 1 instead. So 6x plus 2y equals 10. Now, writing the 2 equations out underneath each other is important for keeping life simpler and keeping track of what you're doing. So that's equation 1 again, the exact same as what we had up here. So now we've made the y's the same, we want to eliminate the y's. But this time we've got a minus 2y here and a plus 2y there. And this is really important because we can't this time compare the difference between the two equations, because the difference between a plus 2y and a minus 2y is actually 4y. But what we could do is combine the two equations together. If we combined the left-hand side of this equation together with the left-hand side of this equation, the minus 2y and the plus 2y would cancel out. So let's work through. So this time, instead of subtracting one equation from the other, we're going to be adding them together. So we've got 10 add 6 is 16x. The minus 2y plus the positive 2y cancel out. And then we've got 6 plus 10, which is 16. So 16x equals 16, so x must be 1. The rest of the process is the same as before then. I'm going to use equation 1 to put x back in. So 6 times x, which is 1, plus 2y equals 10. So 6 times 1 is 6. I'll take that away. So 2y is 4, which means that y equals 2. We then just need to check that back in equation 2. So 5 times 1 minus y, which is 2. 5 minus 2 is 3, which is correct. So in this case, we made the coefficients of y the same, so we had 2y and 2y, but because one of them was positive and one of them was negative, we had to add them together to cancel them out. We couldn't subtract them like we did before. So in the previous question, we had the 3y and 3y that were both positive, so we had to take them away or subtract them to cancel them out. So now I've got 3 sets of equations here for you to look at. All I want you to do to begin with is to decide whether we need to add the equations together or subtract them without multiplying the equations by anything. So I don't want you to change the equations. I want you to look at what you can already eliminate, what's already the same, and decide whether we need to add or subtract the equations. So pause the video and have a think, and we'll talk about it in a second. So in this set of equations, it's the y's that are the same, so it's the y's that we are looking at. So we've got a plus 2y and a minus 2y, so to cancel them out we need to add them. In number 2 here, it's actually the x's that we are looking at, and although it doesn't have it, 2 just means positive 2. So these are both positive, so to cancel them out we need to subtract. A lot of people get this wrong because of the plus and minus signs here. The plus and minus signs are with the y, and we're not interested in eliminating the y. It's the x's we need to look at. So the positive 2x and positive 2x tell us we need to subtract the equations. In the third equations, it's the y's, and again they are both positive, so we need to subtract the two equations. So now pause the video and see if you can actually work them out. So for number 1, we said we need to add the equations together, so I'm going to put a small plus between each to remind me. 3x add 4x is 7x. The plus 2y and minus 2y cancel out, and the 12 plus 2 is 14. Now if 7x is 14, then x must be 2. I'm going to then use equation 1 to work out my y value, so 3 lots of x, which is 2, plus 2y equals 12, 6 plus 2y equals 12, take away the 6 and divide by 2, so y is 3, and then let's just double check that in 2, so 4 times x, which is 2, minus 2 times y, which is 3, is 8, minus 6, which is 2, so it's correct. The second equation, number 2, the signs were the same, 2x and 2x, so we subtract. So we've got 2x, take away 2x cancels out. 3y, positive 3y is where we start, take away minus, and remember a take away and minus is a plus. So 3y add y is 4y. Remember take away is the difference between positive 3y and minus y is actually 4y. And then because we subtracted on this side, we subtract on the right hand side. So 7 take away 1 is 6. So in this case, we've got y equals 6 over 4, or 1.5. It's important to realise that decimals and fractions are okay. You might not always get a nice whole number. So again, let's call it equation 1 and 2. We're then going to use equation 1 to find the value of x. So 2x plus 3 lots of y, which is 1.5, equals 7. So 3 times 1.5 is 4.5. So 2x plus 4.5 is 7. 7 take away 4.5 is 2.5, and that is 2x. So x equals 1.25. And then we can just check in 2. So 2 times x, which is 1.25, minus y, which is 1.5, gives us 2.5 minus 1.5, which is 1. So you can potentially get decimal answers as long as it works in both equations. That's still fine. Equation 3 then, we're looking at the y's and they're both positive, so we need to subtract the equations. So minus 4x is where we start. Take away x, so go down one more, gets us to minus 5x. Y, take away y, cancels out. 1 minus 6 gets us down to minus 5. So minus 5x equals minus 5, x is 1. We could have actually done it the other way round here. We did equation 1, take away 2. If you wanted to keep things positive, you could have instead done equation 2, take away equation 1. You would have ended up at the same answer. So now we've found x to be 1, let's use equation 1 to find y. So minus 4 times 1 plus y equals 1. Minus 4 times 1 is minus 4. So we've got minus 4, so to get rid of it we add 4, so y equals 5. And to check that back in equation 2, x, which is 1, plus y, which is 5, equals 6, so it's correct. Let's have a look at one more example then, which presents a slightly different scenario. So in this case, neither the x's or the y's are the same, and I can't just multiply through one equation, so I'm going to have to multiply both equations. We could decide to make either the x's or the y's the same, but because the y values are smaller, I'm going to make the y's the same. So I'm going to make them both 6y by multiplying the first equation 3 by 3 and the second equation 3 by 2. Now the reason I've decided to make both the y's 6y is because 6 is actually the lowest common multiple of 2 and 3. I could, if I wanted to, multiply the whole of the top equation by 6 to get 12y and the whole of the bottom equation by 4 to get 12y. But it is easier if you keep the numbers as small as possible because that makes the maths easier to deal with. So I need to multiply the whole of my equation 1 by 3. So 3 lots of 5x is 15x, minus 3 lots of 2y, so 6y, and 3 lots of 19 is 57. Multiply the whole of equation 2 by 2, gives me 2 lots of 7x, so 14x, 2 lots of 3y, so 6y, and 2 lots of 27 is 54. Now we need to decide whether we're going to add or subtract. We're looking at to eliminate the y's. They are both minus, so if we added them together we would get minus 12y, so we need to take them away from each other to cancel them out. So we're going to take away the second equation from the first equation. So let's call this one 3 and this one 4, and we're going to do 3 take away 4. So 15x take away 14x is x, minus 6y take away minus, so add 6y cancels out, and 57 take away 54 is 3. So that straight away gives us x equals 3. So now we know that x is 3, we can go back to our original equation, so equation 1, 5 times x, which is 3, minus 2y equals 19. 15 minus 2y is 19. Take away the 15, which leaves us with the minus 2y equals 4. And then we divide by minus 2. So 4 divided by minus 2 gives us minus 2. So we used equation 1 to find it. So let's check in the other equation, check in equation 2. Now it's important to go back to your original equations in case you made a mistake when multiplying through. So don't use equations 3 and 4, use equations 1 and 2. So in equation 2 then, 7 times x, which is 3, minus 3 times y, which is minus 2, equals, so 7 times 3 is 21, minus 3 times minus 2 is plus 6, so that gives us a total of 27, which is correct because that's what we had up here in equation 2. So have a go at these two questions, pause the video, and I will give you the answers in a second. So for this first set of equations, the easiest way to make either the x's or the y's the same is to make the y's the same by multiplying through the second equation by 2. So 2 lots of 5x is 10x, 2 lots of 2y is 4y, and 2 lots of 17 is 34. You might have decided to make the x's the same, which is fine, you should end up with the same answer, so bear with me and check the answers at the end. Now I'm going to call that one equation 3, and I'm going to write equation 1 out again because I've used equation 2 to get equation 3. So equation 1 is 3x minus 4y equals 13. Now we're looking to eliminate the y's, and because they are both negative, we need to take them away from each other. The signs are the same, so we need to take them away. If we added them, we'd end up with minus 8. So we are going to subtract the bottom equation from the top equation. So I'm going to do equation 3, take away equation 1. So 10x take away 3x is 7x, minus 4y, take away minus, so add 4y cancels out, and 34 take away 13 is 21. So if 7x is 21, divide by 7, and that gives us x is 3. Now if x is 3, I'm going to use equation 1, 3 times 3 minus 4y equals 13. So 3 times 3 is 9, so minus 4y equals 4. So if minus 4y equals 4, you divide both sides by minus 4, minus 1. So I'm going to leave you to check that these values are correct using equation 2, but there's your answer. So question 2, I'm going to need to multiply both equations to get either the x coefficients or the y coefficients the same, and I've decided to make the x coefficients the same by multiplying equation 1 through by 3 and equation 2 through by 5 to give me 15. So equation 1 multiplied by 3 gives me 15x plus 3 lots of 7y, so 21y, and that will equal 27. 5 lots of equation 2 is minus 15x plus 45y, and that will equal 105. So let's call those equations 3 and 4. So we are going to eliminate the x's this time. So because we've got a positive 15x here and a minus 15x, we're going to need to add them together to cancel them out. So if we add those together, we add everything else as well. So 15x add minus 15x cancels out. 21y add 45y gives me 66y, and 27 add 105 gives me 132. Divide both sides by 66 gives me y equals 2. Now we can use equation 1, so 5x add 7 lots of 2 equals 9. So 7 lots of 2 is 14. 5x plus 14 equals 9. So 5x equals minus 5, which gives me x equals minus 1. So now you know how to solve simultaneous equations by elimination. And there is another method called substitution. So just remember the key points. You are trying to eliminate either the x's or the y's. So once you've got them the same, you consider what you're trying to eliminate to decide whether to add or subtract. If one is positive and one is negative, you need to add them together to cancel them out. If they are either both negative or both positive, so if the signs are the same, then you need to subtract them to get rid of them, to cancel them out. Good job, and I'll see you again soon.